we will solve the problem of moment of inertia of I section. So this is a problem for which find the moment of inertia of the I section shown about x-axis and y-y axis passing through its centroid. So we have to find its moment of inertia of this whole figure about its centroidal axis. So first of all, we have to determine its centroid. We have to find that where its centroidal axes are existing. So first of all, we have to locate the reference lines. So as earlier I have said that we select a reference line as a line of symmetry. If this is a symmetric figure about a line, then we will select that line as a reference line. So y-y axis is a reference line about which it is symmetric. This figure is symmetric. So we can say the centroid of this figure is lying over this line of symmetry. Now second reference line is this. This is the second reference line about x-axis. This is the second reference line about x-axis. So from here we will find where the centroid of this figure exists. So we will take all distances from here. Now this is a figure symmetric about y-axis. So we doesn't require to find the x bar because x bar is same and lying this line for this whole figure and for these individual figure. If we divide this figure in three parts, three rectangles, number 1, number 2 and number 3. This is number 1 rectangle, number 2 rectangle and number 3 rectangle. Then for all the 3 rectangles, the individual centroids of these individual rectangles are lying over this y-y axis. So x bar for whole figure and for all these individual figure is 0. So x bar is 0. Now we will find y bar. So for y bar is summation ay upon summation a, or this can be written as summation a1y1 plus a2y2 plus a3y3 divided by a1 plus a2 plus a3. This will give us y bar. So first of all, we will find a1. a1 is area of this rectangle. So this is equal to 20 into 2. So 20 into 2 is equal to 40 centimeter square, and a2 is equal to 18 into 2. So 18 into 2. So this is 36 centimeter square, and a3 is 10 into 2. So this is 20 centimeter square. Now y1, y2 and y3. So all y1, y2 and y3 will be measured from this reference line. For all individual parts, we will measure the centroidal distance from this reference line. So y1 is half of this, because the centroid will lie over this here. So this is half of 2, so it is 1 centimeter, and y2 is half of this 18 from here, half of this 18 from here, and but we are measuring the distance from here, so 2 will be added. So 2 plus 18 by 2. So 2 plus 18 by 2 is 11 centimeter. 2 plus 9 is equal to 11 centimeter. And y3. Y3 is 2 plus 18, 20, and plus 2 by 2. Because we are measuring the distance from here, and the centroid of this third figure is lying over here. So from here to here, it will be 2 plus 18, 20, and plus 1. So this is 21 centimeter. So this is A1, Y1, A2, Y2, A3, and Y3. Now this Y bar can be calculated as A1. A1 is 20 into 2, 40 into Y1, 1 centimeter, plus A2. A2 is 18 into 2 into 11, and plus A3 is 10 into 2, and this is 21. So A1 Y1, A2 Y2, and A3 Y3. Now this is divided by A1. A1 is 20 into 2 plus 18 into 2 and plus 10 into 2. So on multiplying, y bar will be equal to, on multiplying this, 20 into 2 into 1, 40, plus 36 into 1, 11. So 11 into 36 is 11, 396, plus 10 into 2 is 20, and into 21, so 420, divided by this 40 plus 36 plus 20. So this will be equal to 6, 5, 856. Divided by 96. So this 856 divided by 96 is equal to 8.916. So this is the centroid of this I section, which is at from here 8.916. So this will lie here, somewhere here. And this distance from here to here, this will be 8.916. 8.916. Now the centroid of this centroid is this. Now the moment of inertia, area moment of inertia for this figure we have to find out. So first of all, this is x-axis axis. This is x-axis, centroidal axis, x-axis. So about this line we have to find out the moment of inertia of this figure. So I-x-axis, we have to find I-x-axis, and this I-x-axis will be equal to I-x-axis1 plus I-x-axis2 plus I-x-axis3. So this I-x-axis is the moment of inertia of this whole figure, I section about x-axis line, and this can be obtained by adding moment of inertia of individual sections about the same x-axis line. So this is for one part, one rectangle, first rectangle, and this is for second rectangle, and this is for third rectangle about the same centroidal axis, about this same centroidal axis. So we will use here parallel axis theorem, and we will find this moment of inertia, individual moment of inertia of each figure about their own centroidal axis, and then we will transfer it to the centroidal axis of this whole figure. So first of all, we find the moment of inertia of part 1 about centroidal axis, this much. This is the centroidal axis of part 1. About this we will find the centroidal moment of inertia of this part, and then we will transfer it to here. So we will use the parallel axis theorem. So for I-x-x1, this will be equal to, for this, BDQ upon 12. This is the formula as we have obtained earlier, plus area of 1 into distance. So distance is y bar minus y1 का whole square, because we are requiring this distance. We are requiring this distance. This distance we are requiring this. So between this line and this line, we are requiring this distance because we are transferring from here to here. So these are parallel lines. So we are requiring the distance between these parallel lines. So these parallel lines we can find out. This is y bar from here, from this reference line. This is y bar. This is y bar. And this is y1. So y1 is equal to 1 centimeter as we have find here. So y1 is equal to 1 centimeter and y bar is equal to 8.916. So if from this we deduct this, so we can find out this value. So this is the difference between these two parallel lines. So we are using this difference as y bar minus y1 ka whole square. So now this will be equal to as BD cube upon 12. So cube of the side which is perpendicular to the axis. Cube of the side which is perpendicular to this axis. XX. Cube of the side which is perpendicular to this axis. So here this dimension 2 centimeter is perpendicular to this axis. This side is perpendicular to this axis. So B is the 20 and cube of the 2 upon 12 plus area is 20 into 2 and y bar is 8.916 minus y1 is 1. So whole square of this. So as this is the centroid of part 1 and this is the centroid of the whole figure. So this is the moment of inertia of first rectangle about XX line. So this is IXX1. Similarly, we will find IXX2. IXX2 will be equal to 2 into 18 ka cube. Now here the 18 is the perpendicular side of XX. 18 is the perpendicular side of XX. So 18 ka cube. 2 into 18 ka cube by 12 plus 2 into 18 area, and this will be equal to 8.916 minus y2, and y2 is 11. So this is the square of this. Now IXX3. Similarly, IXX3 can we find out? So here again 10 into 2 is the perpendicular side, to cube of 2 divided by 12 plus 10 into 2 area, and this is y bar. Y bar is 8.916 minus y3. Y3 is 21 and this is whole square. So like this, IXX1 is this value, IXX2 is this value, and IXX3 is this value. These are from this parallel axis theorem. And after finding these values, we can put these values in this equation number A. So on putting, we can find out the value of IXX is equal to, on solving this IXX, this value, we have received this value 2519.856, and by calculating this IXX2 1128.350, and on calculating this IXX3 2927.127. Now on adding all these three values, 2519.856 plus 1128.350 plus 2927.127. So on adding this, we find the value 6575.333. So this is the value of area moment of inertia about XX axis of this I section. So in this question, to find this Ixx, we calculated the individual moment of inertia about their own centroidal axis, and then we have transferred these individual values to this common centroidal axis by applying parallel axis theorem, and after on adding all these values we can find out the total moment of inertia of the whole figure about x-axis axis. Now for y-y axis. So for y-y axis we will find the values of moment of inertia of individual figure about y-y axis, and then we will add these all three values and get the value of Iyy, because here the centroidal axis along y-y axis is common to all, that is individual centroids of all the three parts are lying on the same line, so we does not require to transfer them to anywhere because x bar is 0. So distance between the parallel line is 0 because they are lying over the same centroidal axis yy. So this is equal to Iyy1 plus Iyy2 plus Iyy3. So without applying any theorem, we can calculate directly by BD cube upon 12. So for rectangle 1, now dB cube upon 12. Now this will be transferred at dB cube upon 12 because the perpendicular side is now changed. Perpendicular side is now changed. So this will be 2 into 20 ka cube divided by 12 because now the 20 centimeter side is perpendicular. 20 centimeter side is perpendicular to the y axis plus 18 into 2 ka cube divided by 12 plus 10 ka cube into 2 divided by 12. So on calculating, the value will be, by calculator we can find out the values 2 into 20 ka cube divided by 12. So this will be 133.33 plus 18 into 2 ka cube divided by 12. So this will be 12 and 2 into 10 ka cube divided by 12. So this will be 166.67. So on adding, this will be equal to 1333.33 plus 12 plus 166.67. This will be equal to 1512.003. 10 to the power 4 centimeter to the power 4. So this is IYY. So now this IYY can be find out by adding IY1 plus IY2 plus IYY3. These are calculated directly because these are not transferred anywhere, because the centroidal axis YY is same as all these three parts centroidal axis. So it is IYY and this is IXX. Okay, thank you. Now in this question we find the moment of inertia of this T section about centroidal axis. So in this question find IXX and IYY for given T section. So IXX and IYY means moment of inertia about centroidal axis. So for this, as earlier, we will fix the reference lines. So this is a reference line about which it is symmetric here also. So it is here this YY line, about this YY line, this figure is symmetric. So X bar is 0, and now to find the Y bar, we will take this is a reference line and divide it into two parts. One is this and second is this. So from this figure, now Y bar is A1Y1 plus A2Y2 upon A1 plus A2. So A1 is 15 into 2 into Y1. Y1 is from here and it is at half of this distance from here. Half of this 15. This is part 1. So from here it is half of this 15. So it is at 7.5 from here, Y1. So Y1 is 7.5 centimeter and it is equal to 30 centimeter square. And A2 is 20 into 2. So 20 into 2 equal to 40 centimeter square. And Y2 is this total is 15 plus 2 is equal to 17, and it is at 1 from upper side. It is at 1 centimeter from upper side. So from lower side it is at 15 plus 1, 16 centimeter. At 16 centimeter, because this is a reference line and we are measuring the distances from here. So from here it is 15 plus half of this 16. So now Y bar is equal to 15 A1. A1 is 30 into Y1 is 7.5 plus A2 is 40 into Y2 is 16 centimeter divided by A1 30 plus A2 40. So this is equal to, on calculating this 30 multiplied by 7.5 225 plus 640 divided by 70. So this will give you as 225 plus 640 divided by 70. So this will give you 12.35 centimeter. 12.35 centimeter. Now again IXX. So XX is lying at here from this reference line. It will be at, this is Y bar is equal to 12.35 centimeter as 12.35 centimeter. So Y bar is from here, it is 12.35. So now IXX is equal to IXX1 plus IXX2. Now this IXX1 by parallel axis theorem, it will be equal to, for first part, BD cube upon 12. So BD cube, B into D cube. So D is 15, D is 15 because cube of the perpendicular side of XX. Perpendicular side of XX. So 2 into 15 cube divided by 12 plus area 2 into 15 into Y bar minus Y1 का whole square. And IXX2 is 20 into 2 का cube divided by 12 plus 20 into 2 is the area, and this is Y bar 12.35 minus Y2. Y2 is 16 the whole square. So on calculating this, IXX will be equal to, on adding these values, we can find out the value of IXX. On calculating these values, this is, on calculating this value, this is 1268.165, and I am calculating this, this is 546.233. So on adding these, both of these, 1268.175 plus 546.233. So the total of this IXX for this T section is equal to 1814.408 centimeter to the power 4. So this is IXX. Now IYY. IYY for this T section. So IYY is along this line. So as similar in I section, this line is common for both these figures, individual figures, because this centroid of this one part is lying over this line, centroid of the second part is also lying over this line, and the centroid of the whole figure is also lying over this line. So this line is common for all centroids. So we do not require to transfer or to apply the parallel axis theorem. So these can be directly added. So this IYY1 plus IYY2, or this is equal to DBQ. Now DBQ upon 12 plus this is also DBQ upon 12. Now the cube of the side perpendicular to the YY axis. So this is, in first part, the perpendicular side is 2. Perpendicular side is 2 to the y axis. So perpendicular side is the 2. So 15 for this is 15 into 2 ka cube divided by 12 plus this is for this before it is 20 into 2 ka cube because 2 side is perpendicular side of x. Now perpendicular side is 20 of this y axis. So cube of the 20 side. So here the reverse of this 2 into 20 ka cube divided by 12. So for first it is 15 into 2 ka cube divided by 12 and for second is it 2 into 20 ka cube divided by 12. So now on calculating this 15 into 2 ka cube divided by 12. So this will be equal to 10. This is equal to 10, only 10 plus 2 into 2 into 20 ka cube divided by 12. So this is 1333.33. Again we are checking 15 into 2 ka cube divided by 12. So this will be equal to 10 and this is 2 into 20 ka cube divided by 12. So this is equal to this. So on adding 10, this total value will be 1343.33 centimeter to the power 4. So this will be IYY and this will be, this is IXX and this will be IYY. Okay, thank you. In next lecture, we will take other type of composite figures.